So understand that oxidation as the loss of electrons and reduction as the gain of electrons. So what we're looking at here is we're looking at the same thing as what we were looking at last. So let me just refer you back to what we were looking at. So magnesium plus copper oxide to give you magnesium oxide and copper. So in this example, you can see that magnesium was in an elemental state as a solid, and now magnesium is in an ionic form as magnesium oxide. So that'll be Mg2 plus ion and an O2 minus ion. And the oxygen, copper oxide here is in like a compound, and here the copper oxide is in the form of copper metal. So we've changed from elements to ions. So this involves the loss and gain of electrons. So we're going to use the same example in order to explain what's going on here. So the next step we're going to do is we're going to write out this equation in the format of an ionic equation so we can see what's happening to the ions. So that is Mg, magnesium solid, plus copper oxide. So we've broken the copper oxide down into the lattice component, which is Cu2 plus and O2 minus, which give you CuO. So we've just broken that apart so we can see more on a molecular, like, or on a sort of an ionic level, what's going on there. So the same then for the magnesium oxide. Magnesium oxide is made up of magnesium and oxygen ions. And then we have our copper solid then at the end. So what's happening is magnesium goes from being magnesium solid with an oxidation state of 0 in its elemental form to Mg2 plus ion, which is an oxidation state of +2. So how has this occurred? So what's happened is the magnesium has lost electrons. So we were neutral, we took away 2 minuses, and now we have a 2 plus. So I'm going to put in here loss of electrons. And the copper is copper 2 plus. And then the copper gets back some electrons to balance out that positive charge and ends up being copper metal with an oxidation state of 0. So this copper has gained, copper ion has gained electrons. Okay, so then if you look at the oxygen, we have O2 minus here. And we have O2 minus here. So you can see that nothing's really happened to this oxygen. So what we call this oxygen is we call it a spectator ion. So when we write an ionic equation, we don't include the spectator ion. So that spectator ion was unchanged in the reaction itself. It ended up with a different partner, but it was unchanged. So we only write down in the ionic equation the ions that are involved. So there you can see the ionic equation. So magnesium plus copper 2 plus to give you magnesium 2 plus copper. Now if you were to write this in terms of half equations, you'd look at what's going on in one half of the equation. So you look at the oxidation half. You look at the reduction half of the equation. So what's happening in the oxidation half? So is oxidized is a loss of electrons, oil rig. So we're looking at the red section above here. So we're going from magnesium solid to magnesium 2 plus. Now there's electrons involved somewhere here. So you always put plus electrons, you don't put minus electrons. So you're breaking down this magnesium and taking away 2 electrons from it to give a magnesium ion plus 2E minus. Okay, now can you see that this is exactly the same as this, which is Mgs minus 2 electrons to give you Mg2 plus. But again, by convention, like what I said to you, we put the electrons with a positive sign, so we don't put minus electrons on the equation. We describe it in terms of what I've written above. Okay, but it's the same thing. In fact, you wouldn't be penalized for it, but it's convention, better convention to write it as the way I've written it in black. So looking at the next equation, so if you look at the blue section down here, we have copper to give copper ion, so Cu2 plus. You have Cu2 plus to give you Cu metal, which has got an oxidation state of 0. So what we need to do now is think about this in terms of electrons. So if I go from Cu2 plus to CuO with an oxidation state of 0, I've had to add 2 electrons, so plus 2e minus here, to give you CuO. So you can see in this example above here, we produced electrons, and in this example below here, we added electrons. So you can see these are the same electrons here and here. Okay, so oxidation and reduction occur simultaneously in equations. They occur in pairs. One thing becomes oxidized and the other thing becomes reduced. We use our acronym to remember this. Oil rig. Oxidation is loss and reduction is gain.